Hello everyone. Today we are going to be looking at the fundamental theorem of algebra. In here, we are going to look at the following topics. We will use the fundamental theorem of algebra to determine the number of zeros of a polynomial function. Then we will also use it to find all the zeros of polynomial functions. If our zeros are complex zeros, then what is the relationship of conjugate pairs? And also find zeros of polynomials by factoring. So let's first look at what is the fundamental theorem of algebra. The fundamental theorem of algebra simply says that if we have a polynomial of degree n, where n is strictly greater than 0, then the function f has at least, very important, at least one zero in the complex number system. I hope you guys remember what's a complex number, because that's very important. The complex number, guys, is of the form a plus ib, where a and b are real numbers. Remember, they belong to, guys, if you remember, they are or belong to the real numbers. And I, very important, is a square root of -1. Okay, let's look at one more theorem which will help us do the problems here. Now, this problem talks about the linear factorization theorem. The linear factorization theorem states that if we have a polynomial of degree n, where n is strictly greater than 0, then this function or polynomial has precisely n linear factors. And we write this function as a sub n, it's a coefficient, guys, just remember that, times x minus c1 times x minus c2 dot 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 x minus cn. Now these ci's, c1 to cn, these are complex numbers. Remember, complex numbers is including the real number systems. Okay, moving forward. Now when we talk about these two important theorems, the fundamental theorem of algebra and linear factorization, they only tell us that the zeros or the factors of a polynomial exist. That's important. They say, oh, if this function is working, that means it is going to have a zero or a factor of a polynomial. That means they are giving us the existence of them, but they do not tell us how to find them. So in order to find these zeros of polynomial, we are going to rely on other techniques. So let's start with very simple examples about the zeros of polynomials. Now, the first degree polynomial, remember, polynomial of degree 1, that's the meaning of it. So this means a polynomial of degree 1. For example, fx equals x minus 2. Now this has exactly 1 zero. In other words, when it says the word 0, that means when you plug in 2 in place of x, it has exactly 1 0, x equal 2. That means when you plug in place of x a 2 in the original function, you should get a 0. Okay, let's look at a second degree polynomial. Remember, these are quadratics. So a second degree polynomial example is x squared minus 6x plus 9. And we're going to count multiplicities of the function. We'll talk about these also in a minute. Now, if I want to find the zeros of this second degree polynomial, we all know how to factorize x squared minus 6x plus 9, and it is given by x minus 3, x minus 3. So that means what? That this polynomial has exactly 2 zeros. Now x is 3, x is 3. Basically it means 3 is repeated twice. And that's the meaning of multiplicities of the function. So as we increase the degree of the polynomial, our zeros can be repeated also. Okay, Let's look at another example, which is a third degree polynomial. Now, a third degree polynomial, let's take a very simple example, say x cubed plus 4x. And we would like to find, because that's what you're doing, is what are the zeros? In other words, what value of x, when I substitute in this equation, if the equal sign means equation also, guys, remember, then I would get, when I plug in the values for x, I would get a 0. So in order to do that, what we do is, we are going to first solve this one. To find the zeros, remember the idea is fx equals 0. Okay, so we put fx equals x cubed plus 4x, take the common factor out. Now let's look at x squared plus 4. Now, we all know if we have, I want to find what would be the value, x squared plus 4 to be 0. Either x is 0 or x squared plus 4. So that means before I actually write down, what I'm going to do is, I'm actually going to find the values for x here. So this x squared, guys, equals what? Negative 4. And we all know x is plus minus square root negative 4. Remember your complex number systems, guys. Negative means you can take the negative out from the square root by putting an I in the front. Square root 4, which is plus minus I 2. Okay, so let's look at this. I want to find zeros of this third degree polynomial. So in other words, I want to do fx equals 0. That means I have to put, let me do another, that is I have to put x times x squared plus 4 to be 0. So one of the values, x is 0, is already here. And the other one is x squared plus 4 to be 0. So before I write down, like if I don't remember the factors, what I'm going to do is I'm actually going to do the work and then come back and put the terms here. So that's what I did. So I found the zeros to be 2i and minus 2i. And if you go back to one of my old videos where I say that if you know the factors, these zeros can be written in terms of the factors. So that's what is being written over here. So x times x minus 2i. So now how do we write this one? Just do a recap of this one. So first we find out the zeros. Here we get that either x is 0 or this whole process, this process. Now I want to write down the factors. So I go backwards. I find down the zeros. Now how do I write that one? Remember, if these are the zeros, the factors would be what? X minus 0, x minus 2i, and x minus of minus 2i, because that is my 0. So when I open this up, this is x minus 2i, x plus 2i. And that's exactly what we have. So sometimes when you're doing problems, you actually do the work and then go ahead and fit in the appropriate expressions needed by it. Okay, so let's look at this next one. We're going to look at a fifth degree polynomial. Now a fifth degree polynomial, I'm taking a simple example, say x to the power 5 plus 9x cubed. And we're going to have multiplicities also. So what you're going to do is, okay, I want to find the zeros. That's the whole idea, guys. We are trying to find the zeros of the polynomial. So in other words, what I'm saying is I want to find what is fx equals 0. Okay, so here I have written down the factorization first. But what I normally do is I actually do the math here, find out the zeros, and then go back and fill this up. So here fx is 0, that means x5 plus 9x cubed is 0. Now x cubed is common, and then I have x squared plus 9 is 0. Now this means that x cubed is 0, that means x is 0, x is 0, x is 0. 3 times x would be 0. Okay, so that's the meaning for this one, guys. Now this x squared plus 9. So let's look at this one. So x squared plus 9 is 0. That means x squared equals negative 9. X equals plus minus square root minus 9. As usual, as the top, if you notice, it is plus minus I square root 9. Plus minus I 3. So what we have done, we found all the 5 zeros. Now, convention is we do not write x, we do not say x equal to 0, 0, 0 3 times. We simply say x equal to 0 with multiplicity 3. Okay, now when we want to write it down, so this one x cubed remains the same. So x squared plus 9 follow the same procedure as I did in the previous one. So I would write this as x minus 0, x minus 0, x minus 0. I'm going to try to use a different. So when I have these three, so I would write this as what? X minus 0. Oh, this is, guys, a little. Okay, let's write it down. So when I've got all my 5 zeros, x minus 0, x minus 0, x minus 0. Then x minus 3i, and then x minus of minus 3i. And then when you open this up, you basically get this. Okay, so here were some examples of finding the zeros of higher degree polynomials. We have looked at third degree, fifth degree, second, and the first. Now, we would like to look at this problem from another angle. In other words, if I give you a function and I say, this function has these zeros, prove that. When you see the word prove that, what it simply means is you have been supplied with the zeros. Your job is to take in each one of them, plug it in the formula, in the equation, given to you. So if I say this function, it's a 4th degree polynomial, has 4 zeros, plus minus I, plus minus 3i. Okay, so our job is to go ahead and plug it. Now let's go ahead and do the first, f of I. Now wherever you see an x, replaced by I. And I'm very, very particular, I am using my parentheses. Okay, so that's so that I get into the habit of putting my parentheses. I to the 4 plus 10i squared plus 9. So I to the 4. Now, guys, remember your complex number system. Your I is written as square root minus 1. Then your I squared is minus 1. I cube minus I to the power 4, 1. You have to remember this, very important. These 4 terms are very, very important in the complex number system. So that's what we do. So when we see I4, oh, I4 is 1. We just plug it in here. I squared minus 1, we plug it here. And then we just simply do our algebra. We get 1 minus 10 plus 9, 9 minus 9, a 0. So that means, yes, this is a 0. Basically, they say these are the zeros. You've got to prove that. In simple words, you are just evaluating this function at I plus minus 3i. You're just proving them, yes, what you said was true. Okay, let's look at f of minus I. It's a nice little practice of algebra, guys. So f of minus I is what? Minus I4. Now remember, because it's a minus, be very, very careful of your parentheses. Plus 10 times minus I squared plus 9. Now minus, remember, let's look at this, minus I4. We're going to do a little bit of our exponentials. This is the same thing as saying minus 1 to the 4, I to the 4. Now anything raised to the power an even number is always positive. So this is I4. That's what I've done. I squared minus I squared, simply I squared. And then just basically repeat what we have here. And we see that f minus I is 0. Okay, guys. Let's look at the last two. We had f of 3i. Okay, so here basically, as I said, it's more practicing and, keeping in touch with our algebra things, computational work. Okay, so f of 3i. So if you've forgotten it, remember f of x is what? X to the 4 plus 10x squared plus 9. Okay, so when I say f of 3i, that means it is the whole 3i to the 4 plus 10 3i squared plus 9. Now, once again, the exponential rules. So it means integerally every term inside the parenthesis is to the 4. And that's we write 3 to the 4, I to the 4, then 10, 3 squared, I squared plus 9. And then we already know I4 is 1, I squared is minus 1, and 3 to the 4. You have your calculators. I hope you know by that if you don't know, I would be very happy if you could actually remember this, some squares and cubes of some numbers. So 3 to the 4 is 81 plus 10 times 9 minus 1 plus 9. We get that just simple, simple addition and subtractions. We get a 0. Okay, let's look at f of minus 3i. That was the last of the zeros. So we plug it in. Remember, when it is negative, you got to be very, very vigilant, guys. Very vigilant. Okay, so we have minus 3i to the 4 plus 10 times minus 3i square plus 9. Now remember, I'm taking minus 3 to the 4. And if you're using your calculators, guys, be very careful of how you input in the calculator. Because minus 3, if you do not put the parentheses, will give you a different answer. So when you're using your calculators to do the work, make sure you put the parentheses inside with minus 3 and to the 4. Okay? So minus 3 to the 4, I to the 4 plus 10 minus 3. I just use a different kind of parentheses so that I could just differentiate between too many of these, brackets we were having. So it doesn't matter. If you like curly, make curly. Whatever, guys, you like, just do it. But be consistent. Okay, so 10 times minus 3 the whole square. Now this whole expression, that I square. And then once again, we're getting the same thing as we are getting here. And then we get these values, do a little addition subtraction, and we are done. Okay, I'm going to stop over here, guys, and in the next session we are going to learn how do we find the zeros of the polynomials. At this point, we just learned about what is a fundamental theorem of algebra. We learned about solve simple problems, and also we learned that if we are given a function and we know the zeros, how do we prove that those are the zeros. So the next one, I'm going to talk about how do we find the zeros of the polynomial function, and we will do some techniques. Thank you.